This lesson is about reflections and translations of polygons. A reflection of a shape is when we flip it over a line called the line of reflection. Think of the line as the mirror, and then the reflection is the mirror image of the shape on either side of the line. We can reflect things over vertical lines or horizontal lines. We can also reflect over a slanted line. The important thing to remember is that the two shapes have to be equal distances away from the line of reflection for it to be a true reflection. A translation is when we slide a shape. On a coordinate plane, we can slide the shape down or up, left or right. For example, this triangle QPR has been translated down 3 spaces and over 4 spaces to the right. We put an apostrophe on the letter to show that it's already been translated. Let's see an example on the coordinate plane. If we have a shape on a graph with an x-axis and a y-axis, after reflecting or translating the shape, the coordinates will have changed. For example, if we take this trapezoid and we reflect it over the y-axis, and then we translate it down 4 spaces, the coordinates will have changed, and we'll need to find those new coordinates for the polygon. First, let's do the reflection. The y-axis is this vertical line, so what we're going to do is count the distance from each point on the right over to the y-axis and go the same distance to the left. Since this point was 1 away from the y-axis, on the right, we would go 1 away on the left. The next point was 2 away from the y-axis on the right, so we'll go 2 away on the left, and so on. That was only the first thing we needed to do, reflect over the y-axis. We still need to translate it down 4. We're going to take each point around our trapezoid and shift it down 4 spaces, and that will make our new shape. Since there's nothing else in the instructions for us to do, we're going to go ahead and find the coordinates of our new polygon after having reflected it over the y-axis and then translated it down 4 spaces. We'll look at all 4 points around and find the x and y coordinates for each of those 4 points. Remember, in the coordinates, x is always the first number and y is always the second number inside the parentheses.